Is Jarvis a possibility in the current world? Iron Man is by far one of the most technically sound and technologically advanced imaginative characters in the MCU. Not only can he visualize a great product that solves major problems of humanity with a business sense, but also a great engineer who can conjure up things that are figments of our imagination. In this video, we will try to explore the most promising gadget of Iron Man, Jarvis, and how close we are to making it in the real world. Of course, it is not possible to match this complete and awesome fictional AI, Jarvis, with anything available in the real world, but let's explore our options. Jarvis, whose name originated from the butler of the family as shown in Avengers Endgame, is an AI program who is the soul of the operations of Tony Stark, sort of a smart assistant. What is AI, or artificial intelligence? These are the machines which are made to be smarter than humans. Jarvis has intelligence the same or more than humans with insane amounts of computing power. The input to Jarvis is voice-activated commands, and the system can monitor multiple modules like humans-like responses to the voice as if we are chatting with another person, very much fulfilling the premise of the Turing test. Neural network enabled and very much a better replica of the most advanced human brain. One-stop shop to manage various systems designed by Tony Stark, including Arc Reactor. Act as a barrier for multiple threats coming to the Iron Man suit, and tasked to take multiple maneuvers to protect the well-being of the suit along with the person who wears it. It can also closely monitor body vitals and suit's strength to alarm wearer on its usage. Can fly the suit autonomously, launch multiple weapons, and control the armor of most imaginative, ultra-modern exoskeleton called Iron Man. Here is how we think we can recreate these modules and make an integrative system like Jarvis. NLP, or Natural Language Processing. This branch of AI concentrates on giving computers the ability to understand text and spoken words in much the same way human beings can. NLP enables computers to process human language in the form of voice data to understand what the speaker is trying to say. It also removes the ambiguity, language limitation, intent, and sentiment of the sentence so we get the clear response. Of virtual assistants like Siri, Cortana, or Alexa, where apart from understanding the voice input, it can also generate the natural language response from the input received. IBM Watson, a supercomputer, could be at the pinnacle of this tech and can be considered as a real-world replacement of the Jarvis voice response module. Neural network. Neural network is another branch of AI which provides human-like reasoning to machines. It is computationally designed to imitate the human brain and made up of layers of artificial neurons or interconnected nodes. It is also called deep learning, which creates an adaptive system that computers use to learn from their mistakes and improve continuously. Like our brain, it can process large amounts of information, such as voice input and photos, and thus it complements the AI machine learning modeling like medical diagnosis, facial recognition, self-driving recognition, and even NLP. There are various models and different ways of making a neural network task perfect. In deep learning, the data scientist gives only raw data to the software. The deep learning network derives the features by itself and learns more independently, just like when Iron Man was designing the suit to fly. Jarvis was directed with certain raw inputs until it figures out the perfect combination of thrusters is achieved to fly as shown in Iron Man. This branch can very much make Jarvis's capability of scanning the internet for certain voice response and creating various links to various sources, or searching someone's face in the plethora of video feeds, or recognizing someone's voice, or making predictions about certain maneuver, along with many more processing capabilities possible in the real world. Operating systems with AI capabilities. What can manage multiple modules within a system that is derived with most advanced fictional AI and various fictional IoT devices? Let's first explain what an IoT, or Internet of Things, is. In a nutshell, the Internet of Things is the concept of connecting any device, so long as it has an on-off switch, to the internet and to other connected devices. So in the real world, an example that is capable of managing AI and IoT devices is an operating system. Operating systems are a way to manage multiple modules, including IoT devices, and are slowly getting embedded with AI in our reality. We have seen our Windows 11 machine responding to, "Hey Cortana, tell me a joke," and hearing an adequate response. In other words, we are already embedding AI in our OS. Not only that, our presentation, speech, and topic writing is slowly managed by AI. While writing this script, ChatGPT was a hot tool that creates a whole professional write-up just from a topic. Not only AI, we can connect various IoT devices to machines that host OS. These devices are controlled with software responsible to manage them and eventually can reside within the OS to be signaled to execute on demand or triggered with an action. You may have seen Raspberry Pi in your home projects, which could be a close example of this. Even though our progress in OS front with AI and IoT, which manages multiple modules, is at basic levels, and to manage multiple modules like the Jarvis manages, it can be thought of as an multi-layered operating system. The system looks like a very master-slave or client-server topology. In other words, when Tony Stark says, "I have connected my suit to Jarvis," in a similar way, we can have multiple machines connected and managed centrally. Let's look at the real-world counterparts. In the real world, this is similar to a distributed operating system. A distributed operating system is one in which several computer systems are connected through a single communication channel. It allows distribution of the entire system, and it serves on multiple real-time products as well as multiple users. Examples that you may be familiar with are Mainframe, Windows Server 2012, Solaris, among a few. Monitoring and applying countermeasures. Jarvis is actively monitoring the whole system and is also doing so many tasks in the background, be it well-being of Iron Man's suit or the person donning it, or tracking certain leads that could be of significance for threats, or keeping track of various incoming threats, be it to the suit or to the whole system where it lives, and many more. This is a huge laundry list. Let's see what systems we have in place which may be a little closer to what Jarvis has achieved in the fictional world. To assess this section, we probably have to tone down on the threats in our world. The systems we design are good at supervised learning, but when it comes to unsupervised learning, we are still getting there. So for our world, threats are different than what Iron Man's world's seen, and so we have came up with our version of solution to avert those. Cyber defense. This is the ability to prevent cyber attacks from infecting a computer system or device and provide threat to sensitive assets. The ability involves taking active steps to anticipate the cyber action by adversaries and counter their intrusion. There are a few advanced systems that are acting as sentinels to thwart these cyber attacks. Sentinel by US Army, Cyber Mimic Defense (CMD) system by China, Cyberdome, a national defense system to fend off digital attacks by Israel. These are a few famous cyber defense systems in the world which are tested by many hacker groups from around the world and have kept those attacks at bay. Air and ground defense. The most advanced air and surface defense systems which can sense any aerial threat coming to the border, be it precision-guided missiles or cruise missiles. It detects the threat and takes countermeasures to prevent it. Here are a few famous aerial and surface defense systems. Iron Dome from Israel, Aegis defense system from US Navy, S-500 defense system from Russia. Medical monitoring. Remote patient monitoring devices in medical care use digital technology to establish communication between patients and medical staff. It provides a mode for clinicians to monitor weight, blood pressure, blood glucose, blood oxygen, heart rate, and ECG from anywhere. In essence, if we are carrying the device, our health parameters can be monitored remotely by a machine, and evasive action like informing medical personnel or calling an emergency can be taken. These are a few medical monitoring system companies: Dexcom, Sensitronics, Residio, Philips Hardware. These companies use implants to sense various health parameters and send data in real time, effectively like Jarvis monitoring blood toxicity or Iron Man. If we assume that we want to create a version of Jarvis in our reality, we may have to assemble the components in a form that can define the features discussed above. It is an integration of multiple systems on a server farm, like the one AWS keeps for its cloud, or using a supercomputer cluster that can connect to these multiple systems. We hope that this has been toggling with your brain to explore more on how to make this version Jarvis better. Please put in your comments, and if you made it so far, please consider subscribing to our channel.